Hi everyone, welcome to the Meltio and CREATE Education and webinar. My name is Mike, I'm the technical lead for CREATE Education, and today we're going to be exploring the Meltio ecosystem across its three machines and how it's being deployed throughout education here in the UK. Speaking today, we've got Brian Matthews, the CTO from Meltio, who will be giving us an explanation of all the different technologies. We've also got Matthew Roberts, PhD student from Lancaster University, who's been using the M450, and Nick Hopkins from the University of Central Lancashire, who has been using the Meltio engine integrated inside a Haas CNC system. If you would all just like to put your cameras off and be on mute, then we can proceed and we'll take a Q&A afterwards to hopefully give any answers to questions that come up throughout the presentation. Please note there is some audio missing from the recording of this webinar. You join us listening to Brian Matthews talking about the dual wire applications of the Meltio system.
So unlike powder bed fusion, for instance, where you're really restricted to working with one material in a given part, we can actually switch materials during the process. For example, with wire, we can switch wires automatically. The switch time is about 4 seconds. So that's something that's really exciting in terms of the capability. Also from a user perspective, it gives you a lot more in-depth capability in terms of making things that have perhaps superior properties than what's been done in the past. So that's something that we're really excited about. The products we have right now are the Meltio M450 printer you see on the left. We started with this system 2 years ago. Most of the installations have been with education, university, technology centres, but we're also getting into production space. This machine has shown a lot of capability to do production runs. So that's something that's really important to us in a scalable strategy as we expand into the wider market. But we took the technology that you see in the M450 and we kind of repackaged that into a different form factor to create the Meltio engine, which you see in the center image there. It's a small box, if you like, next to the right of the CNC machine. And so that small box contains the laser system, power supplies, all the control boards, everything that's needed to run the process. And the deposition head is installed inside the CNC machine. I'll show that in more detail in a moment. And that gives a really unique capability to do hybrid manufacturing. The same setup, the Meltio engine, can be used with robotic systems that you see on the right. And that really opens up the capability to large format printing, more complex shapes, thanks to the multi-axis capability of a robot. And so those are two really strong growth areas for us. This slide here shows an example of how the process works. Sorry, I'm not sure what that link is not working here for some reason. But the image on the left shows the Meltio M450 printer, and the deposition is very clean. As you can see on the left, there's no debris on the substrate when you're printing with metal wire. And that's because 100% of the material ends up being utilized in the process. In a powder blown process, you would see a lot of powder contamination around parts. And so that's something that's, really a wonderful quality of metal wire processing. It also leads to the lowest part production cost. I think that's really viable because metal wire is close to material commodity pricing. So if you're using the lowest cost material and you use all of the material in the parts, it gives you this kind of de minimis level of cost optimization that I think's really hard to beat. I don't think any other process can beat that, for those reasons. The CNC integration shows what's possible really with the technology in terms of getting to a final part in one process. So it gives you the capability to print a part in one code, and that same code can actually come in and automatically machine finish the part, whether it's in tandem with the printing or if it's sequential after the printing is completed. So that's a great solution for a customer that needs the final part in one process. Also, it gives the possibilities to do repair work, where you can actually come in with an existing part and remove some material and add material back. It also allows you to do part augmentation, where you can actually look at a part and optimize it by manufacturing a part in another process, and then bringing it into this system and adding features to the part. So it's a really flexible, solution. And then robotics, you see on the right, really shows what's possible in a really fun way. You can do these really large parts, complex geometries. And that's something that's really had an explosion of interest in the past 6 months. We've recently exhibited at Form Next in Germany, and we had perhaps 200, 300, 400 parts on display. Many parts were robotics, and yeah, there was a lot of excitement about those products. The type of parts you can print are really illustrated on this slide. The thing to know about the M450 is that it was a system that we really conceived for the education, university, research centre segment of the market. But it's really proven to have a lot of just really wide applications. For example, you see just a random range of parts here, but on the left you've got watch bezels. So for the wearables sort of industry, that's something that we didn't anticipate, but is shown to be very viable from an economic standpoint to use the technology for these types of products. And as you march through those samples there, we've got an automated piston, rocket nozzle, and then we've got large parts that are from sort of mold and die industry, as well as aerospace parts for brackets, junctions, and then on the far right you see this really large glass mold part, a 15 kilogram part that was done on the M450. All of these parts were done with metal wire, so these are as printed, no machine finishing. But again, if you want a one-step process with machine finishing, then the image in the center of this slide, shows that possibility where you can actually print a part and machine finish the part in one process. So you can see both as printed and machine finished there in the same image. And then on the right, you've got the larger parts that we just talked about with the robotics. Of course, that's a two-step process, but what you can achieve in terms of geometry, and dimensions is quite spectacular from my perspective, at least, and it's scalable as well. Just like the model of our company, the technology is also scalable in terms of the types of things you can make. And robotics is a really great scalable strategy for getting to progressively larger parts. So, that's something that's, like I said, had a very strong interest in the industry in the past several months. Right now, we have this pretty comprehensive ecosystem. I mentioned we're in 25 countries. We have over 25 partners, 35 in the channel in terms of integration partners, value-added resellers, master resellers. And that's just something that's really important to us. So the key thing to note is that we work in a way that's very much in partnership. So we don't do transactions. We're not a transactional company. When we sell a product, whether it's to an integrator or to a master reseller, value-added reseller, we work hand in hand all steps of the way. And many times we're actually on calls with our channel partners, and we're doing calls together. We're assisting. In some cases, we actually visit the customer end user sites. And so we see the channel partners as like an extension of the company. That's really important for us. And it might sound obvious, but we put a lot of energy and a lot of effort into making sure that works in a really seamless way, because this allows us to scale very fast. I mean, we couldn't be in 25 countries, without this model. And this model wouldn't work unless we worked in that way. So I couldn't really emphasize that enough, that it's really important to us to have a really strong ecosystem. And we are always there, front and center. We like I say, we don't have a transactional business where we sell a product and then on to the next customer. We don't work that way. And I think that philosophy has really been validated. When I look at the sales last year, for example, in the United States, we had 2 customers that bought 3 systems from us. And those three systems are the three varieties I presented here in this presentation, where they started with an M450, they came back for a Meltio engine for a CNC hybrid integration, and then they came back again for a Meltio engine for a robotic integration. So, and all within the space of 12 months. So I think that's a really great metric for us. We're really proud of that. We're really happy to see customers trusting in us in this way and coming back to the same product, or in some cases other products that we offer. So that's something that's been a really good result for the company, and helps give us confidence that we have the right model. Okay, back to you, Michael.
Brilliant, thank you, Brian. So, as you sort of mentioned, Meltio are quite a young company, and the job of education is to prepare young people for future employment and to look at the technologies that they're going to be facing. Obviously, the last 2 years have been difficult for everybody, and global movements have been much harder. How have you found the Meltio technology being used in industry? Like, what sort of fields are picking it up, and is it a shift into localized manufacturing? What's the feel on the ground?
Yeah, so we have this kind of a sensible strategy where we started really with a lot of strong focus on the education sector with the universities, and then sort of quickly migrating into technology centers. And the technology centers, could be government research laboratories. We have a number of those in the United States, for instance, but also, commercial companies that have their own technology centers where they want to promote new solutions, do innovations. So we put a lot of energy into those two segments first, and then we've been getting into prototyping for the commercial industries. And then from the prototyping, we've been progressively moving to mass production. So we actually have a few customers now that have mass production applications. So I think that's something that the technology is being really driving in that direction very fast. And the reason for that is when you look at the analysis of the process. So you've got a low cost machine, relatively speaking. It's a low cost machine compared to other options in the market. But the machine uses an open materials platform. So we don't tie down the customer to an expensive material. Also, we're using metal wire in our process. Metal wire is close to commodity material pricing. For example, single-digit dollars per kilogram for stainless steel. And all of that material in our process is utilized. So in a powder bone process, typically 50% powder utilization is quite normal. In some processes, it's actually less than that. So you get this huge cost advantage where the material is the lowest possible form for a realistic commercial application. And all of the material gets used, so there's no wastage. And so that's really driven to this combination of the lowest cost materials, the open platform, the low cost machine, that feeds into this really low part production cost. And that's been driving the mass production applications. So that's something that's we felt was inevitable looking at the fundamentals of the technology. But of course, to get to mass production, you need to have extremely high levels of readiness. Technology reliability factors have to be very, very, very high. And in the last, I'd say, particularly in the last year, we've achieved a very, very high level of readiness with the technology where, to this day, where we look at customer requests for parts, and typically very little time needs to be spent to produce the result. And in most cases, it's first time success. Right now, our systems run mostly unattended. That's something that was kind of like a dream, to be honest. If I go back 3 or 4 years, the vision of being able to take a CAD model, generate the toolpath within literally an hour or less, run the machine, and then to actually move on to some other task while the machine executes on the part, that was like the vision 3 or 4 years ago. And I'm really happy that I believe we've got there already. And of course, there's always continual improvement, but the machine performance is very high in terms of readiness level now. So the combination of cost and that important aspect is driving this mass production possibility.
Thank you, Brian. I think it's worth adding as well for some of you on the call. I'm not in the sales field. I'm a technician, so I'll give you the sort of technical aspect of it. But one of the big advantages of Meltio is the press to print time. It's like 60 seconds from pressing print to starting the print. There's no waiting for heating up and all that kind of stuff. And it is literally press print and walk away. And that for in the education sphere where you're not having to wait 3, 4, 5 hours for a heating chamber or an argon purge is a big advantage for me. So I'm going to move on, and I'm going to bring in Matt Roberts from Lancaster University, and we're going to learn a little bit more about how their system is being deployed in education. So Matt, can you hear me okay?
Yes, I can. Can you hear me?
Yes, perfect. Hopefully everybody else can too. So nice easy question to get you rolling. Which of the 3 systems that Brian spoke about do you guys have?
We've got the Meltio M450.
Perfect. So just for the audience, that's the standalone version. It's actually the one behind me. It's enclosed, easy to be deployed. And what are you using it for?
So I'm a PhD student, second year PhD student, and we're using it principally for research, looking at process optimization techniques and material characterization, so that you can print with new materials and really get to the optimum parameters, printed parameters for those as quickly as possible. And also managing the temperature effects through a print and how that affects material properties and part geometry.
Perfect. So it's very much a research machine for you guys, not get the students involved type of kit, but I presume they get to see it and understand, how the technology works and what the process is as well.
They do, and we have a small number of 3rd and 4th year projects at work with the machine as well, and they really enjoy working on it. So yeah, it's principally focused on research, but yeah, they do it in the labs and they do have access and do work with some students on it.
Brilliant, that's great. So obviously you've been using the kit, you've got into it, and it's a new to market technology. It's not something that's out there, it's not been replicated many times. What excites you about it? What do you find is the key benefits?
I suppose it's been touched on a little bit already. The speed, really. We're not. We've never had metal wire printing facilities here before, and my background certainly isn't metal additive manufacturing. So, firstly, the speed of kind of getting using the technology and sort of being able to produce parts relatively quickly. I was quite pleased with how quickly that happened. But then, we have ideas about experiments we want to do, and we can quite rapidly sort of design that and get on a machine and print it and remove parts to assess afterwards in really short time periods. So it's really it keeps you very motivated to want to push on and do more as well. So yeah.
Right. And have you found? I presume that your PhD is involved in adding extra features or lost data gathering. Have you found the machine easy to work with in terms of adding bits on or pulling data from it, that kind of stuff?
And I'd probably say as well that support from Meltio has really helped from that as well. So we've put a couple of extra sensors in the machine around the head. You can just see behind you. So we've got we can measure temperature and part geometry in process, and Meltio have been really helpful in sort of talking through our ideas and how we can achieve them well and sort of protect the machine and protect our equipment. So yeah, and actually we can sort of print parts quite easily, but we can also sort of do more and control the process quite well as well when we're interested in specifics in the printing process. So it's really helps from that perspective.
That's brilliant. And how do you find the parts that come off? I mean, we're not in the fancy lattice geometry. I always say we're in the sort of heavy parts, the big net. How are you finding the ones that come off?
Yeah, they're good. I mean, I'd say it's near net shape for sure, and the quality of the parts. It does depend on, you've got to refine the process. You've got to think about how it's going to print. It depends on the shape, and so if there's finer detail, you've got to think that through and plan it well. As with any other additive process, I suppose. We sometimes see a little bit of porosity. Again, it's about thinking about how we print it, which we can overcome. We have done with the prints that we've done. So yeah, we're really happy with it, and we're starting to produce more challenging things as we learn more as well. So yeah, it's good.
Excellent. That's really good to hear. So, what are you seeking to improve with your PhD and your research?
Recording in progress.
Yeah. What are you trying to solve?
So, I suppose it's sort of looking to sort of fill the gap between where the process planning, the tool sets at the moment finish when you have your G code to go in the machine, and when the machine starts. So we're looking to be smarter about how you choose and control process parameters through the print process, so you can really get consistency and really good part quality. But also, I think that as the technology matures and the sector grows, the ability to just put a wire that you can buy into the machine and print with it means you're going to get more materials you wouldn't necessarily be able to use in other production processes and applications. So having the ability to really to understand how those materials behave and how you can print with them and profile them efficiently without too much waste is the other real sort of driver for us in terms of the research that we're doing.
That's fantastic. Well, especially for an open material platform, I think to be able to almost have a formulaic approach to new materials where it's not a complete guess going in, especially if the system starts to get deployed in industry. To have a rough place to start, I think is excellent. Well, again, really good. So we've obviously covered what you guys are using for in your research. Have you considered any partnerships with the local businesses and sort of reaching out that way?
My PhD is funded through a wider program. It's about partnering with other industry companies in the northwest of England. So we've had a few different companies through that have expressed an interest in producing parts and novel designs that with the machine, either to cut cost or material waste on more expensive materials. And we've done a few sample prints for them, and we're sort of mostly focusing on the research activities at the moment, but sort of looking into the next 12, 18 months, we are looking to sort of develop those partnerships with the companies as well. Yeah, they're interested particularly because we can produce parts and we can produce the sort of bits and pieces that look relatively dull to most people, but are really interested from a research perspective as well. So it kind of gets both people interested in it.
Yeah, there's so many parts that you start off that are cubed or tracks, and they look so dull, but they're so important when you put them in half and you start seeing, the Meltio system is producing massively dense parts. And for those of you that are doing sort of CNC work, there's no grain to the metals or anything like that. And a cube may look boring, but it can actually tell a very, very big story. And it's everybody's first print off Meltio, that's for sure. It's the calibration cube that we do. So if I brought the Meltio Fairy with the magic wand and I said you can have, any kind of improvements, anything new, where would you go? What would you like to see in the system?
Question. I think for me it's two things. One would be the main the bit I like least about using the machine, which is removing the parts from the printer substrate. It's the metal's obviously incredibly hard after it's been through this process, and you've got to cut them off and clean and prep the plates again. So making that easier and quicker so I can spend more time on the machine. I think that's something that's an issue with working with any metal, and certainly in these kinds of processes, but it's the one everybody likes the least. The other one would be to be able to print with finer wire diameters as well, and get even more detail in the printing process. It would be amazing to be able to do, and I hope that in the future that will be possible too.
Yeah, that's it's worth saying to the audience so that the Meltio system primarily works on a 1mm wire. It can work on anything from a 0.8 to a 1.2. We just have a nozzle tip that we can change over. So 1 mil is about where we work at, with a bead width of about 1 millimeter as well. So that gives you an idea of where we sort of pitch. And as Matt says, the desire for higher fidelity wires is something that will be on his roadmap. There's a few questions come in. We'll get to those at the end. But for now, Matt, thank you very much. That's been brilliant. And we may come back to you at the end.
Cheers.
Okay, great. As I say, if anybody wants to pop questions in the chat, I know there's a few been in there already, then we'll get to them in a Q&A at the end, and maybe Brian can cast an eye over them and prepare any answers that are on the Meltio sort of ecosystem roadmap, and the same for you, Matt. So now we've got Nick Hopkins from University of Central Lancashire. You'll find referred to as UPlan. I can sort of lead Nick into what he's doing because he's got the engine. So we're representing both systems today. What system have you got it deployed on, Nick? You got the engine. Is it the CNC or the robot?
So we have the engine deployed on a 3-axis Haas mill.
Okay, great. Finding it okay?
Yeah, it's great. It's yeah.
And what are you guys using it for?
So we use it for student learning, allowing our students to have access to the sort of cutting edge technology, as well as using it for research, particularly looking at potentially repairing parts that are broken or machining parts, but reducing the amount of billet needed to do that.
Yeah, I think we've seen quite a lot of that actually. But again, if you guys want some of the videos that I know Brian couldn't show in the slides, the Meltio social channels have all the videos on there. There's a great one for repair production on these are glass bottle mold on the Meltio socials. So for you, Nick, what's exciting about this technology? What sort of draws you to it?
So the use of we have the dual material set up, so that's a pretty exciting addition to it. We can do well, obviously multi-materials with separate properties. You can have hard face on one section and normal steel in another place. Some of our researchers are using it, potentially looking at using bonding multi-materials as well.
Okay. So looking at how the two materials bond to each other.
Yeah.
So I guess that's probably something that's not massively available in the market. I don't think, from my knowledge, there's not too many dual materials systems out there. So the research into how multi-metal parts behave under things like heat and stress, that kind of stuff would be a great field for research.
Yeah.
So talk me through the sort of hybrid process then. How obviously Matt has a nice STL file to load up and press go. How does it work for you guys?
So we do the CAM. We do it all in Fusion 360. So it'll do it'll slice it and do the 3D printing toolpath thing, as well as the machining all in one NC program. So it'll print the parts. The Meltio head will stow away in its compartment behind a door to keep all the swarf out, and then the machining head will do all the machining parts.
Brilliant. And that hasn't impacted on the ability just to use the CNC as a standalone machine?
No. It's exactly as it was.
Brilliant. That's good, because I fitted it, so if it's exactly as it was before, I'm quite happy.
The only downside is the tinted windows now. It's hard to see.
Yeah, I can imagine. But they were always tinted with grease oil anyway before, weren't they? That's the general CNC operator's approach.
Yeah, you don't need to see it anyway.
No. So how are you finding the parts that come up?
So we're experimenting with the different profiles that they make in terms of laser power and deposition feed rate and wire feed rate. But generally, we've got sort of different profiles that work for different sort of shapes of parts, and as we develop them, they're becoming more and more reliable. So that's pretty much it. They're good. They're great.
That's good. And have you sort of considered being able to use sort of billet stock and building on features onto that and adding parts on rather than building the whole thing?
Yeah, so we achieve parts that way where there are small features on top of a large part, which if you were to machine the billet, obviously would just be a lot of wasted time and material. So just add print on the part and then machine the tolerance, the contact faces to tolerance, and go from there.
Brilliant. And I'll ask you the sort of same question that I asked to Matt then. Have you considered sort of working with local businesses and showcasing this technology and the research that you're doing, or is it something that you lock behind the doors?
We're open to having companies come in and do it. We do it in partnership with CREATE Education, so they generally organise showcase days. A few of the local aerospace companies have come and had a look round. So I think anyone local who wants to have a look round just needs to contact CREATE Education.
I think that's just a message all around, really. It's not just for us as CREATE Education, but for the people globally. I think working with your local technology centres, universities, there's such a huge bank of research there. And I think you'll probably back me up, Nick. It's really nice when people bring real projects and real applications to you for research rather than the dummy scenarios that can get created for student-led research. Real life projects are so much more valuable.
Yeah, definitely. It's a lot more motivating to have an actual use, a final use part to make.
And so again, with the sort of Meltio Magic Wand, what are you guys looking to improve? What would you like to see sort of work for you guys?
So we're sort of looking into how to optimize the print process to reduce thermal stress. Sometimes if you're printing onto a thin bed stock, it can slightly warp it. But we're just trying to come up with ways of reorienting the print directions, things like that, temperatures, speeds.
And you think you guys might look to move to a sort of 3+2 axis and try and go down that route, or are you happy on the 3?
Happy on the 3 for now, but we do have a trunnion to add if we run out of things to do.
Project. Brilliant, that's excellent. I hope that gives a sort of flavour for everybody as to what the sort of system is. There's a few questions popping in, and as I say, we've got experts here on the call. I'll try and facilitate. Well, Brian, have you got any prepared answers to any of the questions that have been popping in while me and Nick have been speaking?
Yeah, well, I can just talk on the fly and address some of these. No problem. I'll just take a few of these just to kick that off. So the first question here that popped up was, will this system work in a zero gravity environment? We're actually working quite intensively on an opportunity to use this technology on the International Space Station. So that's something that's we're exploring. But the technology is definitely very well suited for that type of application because with the metal wire process, you don't have, like in a space environment, you don't want to be blowing metal powder or any particulate for safety reasons, health and safety reasons. So metal wire is really ideally suited. We have done print testing, terrestrial print testing, at 90-degree angles. We've even printed upside down, 180 degrees with our robot. So that tells us that the ability to use the technology in the zero-G environment is going to be very good. And also, there's been a number of research studies we've done with universities where we've postulated about the potential material property improvements you get from a microgravity environment. So it looks very, very interesting. Kind of watch this space on that one. A couple of other questions here. There's a question here about the channel. How do you work with us? The best place to start is just make an inquiry through the meltio3d.com website. And I can assure you, you'd get a response very fast. Our sort of global sales channel manager is Gerard Garcia. He's very good, very nice to work with. So yeah, make the inquiry through the website, and you'll get a very quick engagement from someone on the team. There's some other questions here. What's the lifetime of the CNC machine parts when you use powder in hybrid manufacturing? So the thing to note, our strategy with powder is that we really kind of recommend powder use for robotic systems where there is little to no concern over contamination issues with the powder in moving parts. In a hybrid manufacturing system, it's kind of case by case where we look at the machine and make sure that powder spray contamination onto moving structures like the linear rails, guides, etc. It's not a concern. So that's the first thing to note. And our channel partners who do the integrations, they're the ones that are best placed to advise on that. But for the most part, you want to be using metal wire in a CNC hybrid environment. You don't really want to be using powder. You do only want to go to powder if you had a situation where the material is not available in wire form, for instance, because even from a tolerance or resolution standpoint, in a hybrid environment, you can actually mill down to whatever you need. So for the most part, I'd say 99% of the interest in the technology in a CNC hybrid environment is actually with wire, not with powder. Yeah, just looking through. Sorry, a lot of other questions coming through. I'll take one more here and I'll kick it back to you, Mike. Yeah, it says, when customers buy your M450, what is the average time of return on the investment? That's a really good question. And so, of course, it depends on the sector or segment they're working in, how many application studies they have with their customers, and so on and so forth. I can tell you, though, from a real-world practical application standpoint, we have done application work, for customers, and the return on investment, if we were working in that spirit, in a business sense, would be very fast. So I think the range can be from the order of a few months to a couple of years, all depending on how you use the machine, because the machine gives you this research capability and allows you to make things that traditionally haven't been made before. I mean, multi-metal parts is a really great example. Producing large complex structures is another great example where it really hasn't been viable before. So I think with the right application, with the right business mind, with the right energy, the return on investment can be very fast.
Brilliant. Thanks, Brian. I'll pick up a couple. I've got two questions from Simon Lee that I'll split between myself and Matt. So the question is, for other AM processors, they've been developing hardware and software for the AM system that helps best develop the process parameters for new materials, almost on its own. Is that kind of function available for Meltio, considering the open materials platform and the scope of materials that end users want to throw into them? The ability to detect and create a profile for the system isn't currently available, but Matt, I think that's something that throughout your PhD you've been working on as a sort of machine learning type of algorithm. Correct me if I'm wrong and fill in any blanks that I don't know.
Yeah, I mean, I can't really speak for the Meltio roadmap itself, but it's very challenging to do it because of the different properties and behaviours of different materials. And we've been using machine learning tools to do that. I would say that what's helpful is that you can print a lot with lots of different parameters and really understand how the characteristics of the machine perform, and really explore its properties quite quickly. But yeah, as far as I'm aware, there's a lot of activity in the field, but nothing specific to do that in a tool set yet.
Yeah, there's no tool in existence at the moment. So Matt's sort of research and collaboration with Meltio, this is the kind of thing that education partners offer. So to be able to work with these universities and add that functionality speeds up the R&D process and gives real applications to the research that people like Matt are doing in, say, machine learning and mapping out how different materials operate. And that can be everything. We've got a couple of questions on powder, but everything from, we've got proven profiles now for titanium, Inconel, various grades of steel and types of steel. There's development going on for copper and, aluminium, and the ability for us to do things like flux core wire, so powder within a wire. So the ability to really push the boundaries and combine education research is really novel at the moment. And I wouldn't say because there's something not there in existence on Meltio's roadmap that there is no space for collaboration with the company themselves. They are very open for R&D, as are we at CREATE Education. We're happy to do letters of support for funding bids and calls to take the ideas that we have in academia and push them forward. There's also a question about, is there any scope for putting existing parts or structures into the M450 for additional material cladding? Yes, there is. So the way that the system works, we find the home by using a small print arm that comes down, and that touch-off arm here, just with my finger, finds the base plate. So you can use that to find Z0. And because the base plate has fixed mounting points, you can use that to find your datum to start off with. So the datum can always be either XY home or a particular datum on the model. There's no like sort of CMM process in there, but the touch-off and the high accuracy of the print allows you to go on top of other features. Obviously, it's a 3-axis system, so we're not going to be rotating the head in and around parts, but to do basic additions, repairs, cladding, yes, very, very possible. A question from Paul Quinn regarding powder. Let me have a look. What is the timeline for using powder with the head? And Brian touched on this, obviously. The enclosed systems, powder is not the ideal solution because of the enclosures. And can you use, so there's no timeline at the moment. We sort of work on a case-by-case research basis. The recommendation is obviously go with wire because it's better and it's easier, it's cleaner and it's safer. From the health and safety point of view, you've no powder handling, you've no goggles, masks and gloves, we're just wire based. But then for the ability to do powder and wire at the same time, in theory, yes, this can be done, but as I say, the recommendation is always to work with the wire. Average cost from Arcturus Engineering. I think we can come back to you on that one because I don't know what country you're in off the top of my head, so I can't give you a price. But we tend to sort of look at somewhere around 180,000 to 190,000 for the system and the integration. Okay, Brian will be able to give you a better answer on that. I think probably something that you can pick up privately with the Meltio reseller in the area.
I think again, you know, those types of questions, if you go through the website, you make the inquiry, someone will get back to you very fast. You know, we're a very transparent company, so essentially we have the same pricing throughout the world. It's just in the sensitivities of exchange rates, those kind of things that need to be taken into account. But yeah, the price point, we're trying to get it right down to a level where it really blows the doors open for moving the technology into mass production. So yeah, we're always striving to make the cost as low as possible. I think we've done a good job so far, and that'll keep getting better. Can I just add one comment, Mike, on the materials? So Meltio just in the last 2 weeks launched its material portfolio. So what we're trying to do there is we're trying to just make it really, again, removing the friction, right? So you look at the sale process as friction, right? It's a price point, there's how easy it is to use the machine, et cetera, et cetera. And we're just trying to remove all these layers or these barriers. And so one barrier, of course, is yeah, you're using a new material and okay, you don't know the exact settings for the materials, et cetera, et cetera. So we're actually qualifying materials. We tested probably 25, 30 different materials. Right now we have about 5 or 6 that are fully qualified. Fully qualified means independently lab tested. And if you go to the meltio3d.com website, you can see material properties. It's all published, where you get the material and mechanical properties data. And so by purchasing those Meltio materials from Meltio, sorry, just a bit of a, yeah. Oh, sorry, yeah, it should be fine now. It's had to mute someone. Yeah, so using the Meltio materials, you get that benefit of up and running very fast. So, yeah, so anyway, that's just something to note. But the material, like the software, is open, right? So So we don't tie down the end user to working with a material or a software solution that they're comfortable with. You can absolutely 100% do that. We're just trying to remove any friction in the process for customers that, you know, just want to get moving very fast.
Maybe they don't have a strong background.
Okay.
Okay, brilliant.
Back to you, Mike.
Final two questions then, and then we'll wrap up with a bit of a summary. So, does Meltio foresee making different wavelength lasers available to use to allow aluminium wire use? I presume that's not going to be changing the wavelength of the lasers, but maybe what's the plan for aluminium, if there is one?
Our material strategy is basically, you know, we have the qualified materials, then we have the R&D materials, and then we have the materials that are under investigation. So, as I mentioned, we tested 25, 30 different materials. So aluminum is one of the materials, including copper, that's actually in the investigation phase. And you know, we plan to move that into the qualified space at some point in the near future. I'm hoping aluminum gets qualified this year. It's basically just step by step. It's like everything when you're growing a company. There's just so many materials. And so we just logically looked at the market, looked at what most materials are most important to customers, family of stainless steels, the family of nickel-based alloys like Inconel, the family of titanium alloys. And we started there because that addressed most of the sort of demand issues. And then now we're getting into the more complicated materials, copper and aluminum, and then including refractories. You know, we've done some work with some really complicated refractories like molybdenum. So you're going to see a lot of materials in the qualified space. If it's not in the qualified space, it doesn't mean say you can't use the material. It just means we've published data on material and mechanical properties that might be helpful and get you moving much faster. But I do expect that at some point this year we have some qualification.
We have some qualification of aluminum and copper. And final question then is from Arctus Engineering again. Does this system require inert gas such as argon, like standard DED? Yes, it does. It uses a localized shielding, so we're not full chamber purge. In the head, we create a localized shield around the melt pool using an argon supply. We just buy bottled argon. It's from our local welding supplier and operate the system that way. It's very low usage on argon, particularly compared to systems that are out there, things like Metal X. You know, those kind of systems where there's quite a high argon usage. The Meltio system is really low, even when using the more reactive things like titanium. Okay, just to summarise and to close everything off, I'd like to firstly thank our panel, Matt Roberts, Nick Hopkins, and Brian Matthews for their contributions. For Meltio and to Joe Morell at CREATE Education for their efforts in marketing and spreading the word on what is a fantastic technology. My advice to all of you for more information, firstly, I've got another question from Yas about why I'm making machines that I don't know is the answer. I don't know what's in your industry, but there's nothing from Meltio. What I would do is to reach out to your local Meltio reseller or go through meltio3d.com for a centralized answer. The Meltio socials have lots of great video content and being able to sort of produce things through that. And just stay in touch with the systems and reach out to your local suppliers. Thank you very much. Okay.
Thank you.
Bye all.